Hey guys, this is Carl, and we're just going to touch base and go over week 9, problem number 1. So we'll go ahead and kick off with a question. In 2 consecutive years, a large corporation bought 2 failing electronics stores, Store A and Store B. The stores kept their original names, and customers can purchase products from either store's website. And so, for instance, if a random sample is taken of the mixture of recent purchases from these 2 websites, the distribution of the amounts of purchased will be bimodal. And so we'll look at part A real quick right here. As the sample size increases, the sample distribution of the amounts purchased will look more and more like the population distribution, bimodal. So what is bimodal? Well, bimodal is essentially the key word, or root word rather, by two. So there's 2 peaks to this. So, and it's very important to know that when you talk about this, that they are the local maximums in the chart, the most frequent purchases, most frequent recent purchases. So this does not refer to the most frequent appearing scores, such as the central tendency mode. Rather, bimodal distribution is looking at the local maximums. So there's a difference between the local maximum, or the mode, versus your frequency. So we'll get on to the second question. As the sample size increases, what is the expected shape of the sampling model for the mean amount purchased of the sample? So naturally, the key point here and the key phrase is as sample size increase. So as your sample size increase, you are more likely to reflect your population distribution. It's natural. The fewer samples that you have, the smaller the sample size, the less likely it is to indicate the distribution of the population itself. So the more increase in sample size, the more likely you are to actually be reflective of the population itself that you're analyzing, either in this example or just kind of broadly. So it's kind of a general rule to apply. So as the sample size increases, the expected shape of the sampling model for the mean will be normal distribution. So when we're looking at normal distribution and thinking about normal distribution, what is that? That is our bell curve. That is the traditional bell curve. So when you say normally distributed, what does that mean? It means the mean equals the median equals the mode. It's a symmetrical curve. 50% is less than the mean, 50% is greater than the mean. So as your sample size increases, the sampling model for the mean will actually be reflective as a perfect bell curve. So again, to our point, the more likely and more you are to increase your sample size in looking at this, the more you are to reflect the population distribution. That's kind of a general rule applied. So we hope this helps, and just let us know if you have any questions. Thanks so much.